We have that. Right, so for the odds for rolling a die and getting a 3. Okay, well, how many ways can we get a 3? How many ways can that event happen? Well, one. There's only one way that event can happen. Only one way that event can happen. Right? You just roll a 3. How many ways can we not get a 3? So in this case, again, the event is getting a 3. How many ways can we not get a 3? We get one of the other numbers, and we get one of the other numbers. There are 5 other numbers right? You know, there's 1, 2, 4, 5, 6. The odds for getting a 3 are 1 to 5. Fix that. Yeah, now I'm happy. It's 1 to 5. You could also, if you wanted to, we could have also solved it using probability. That's what I'm doing down here. The probability of rolling a 3, as we saw, is 1 out of 6. That's probability. And the probability of not rolling a 3 is 5 out of 6. And this is by what we saw in the second slide. I think they call it a complex fraction. But basically, you take away these denominators. You could do that by multiplying top and bottom by 6. But what you end up getting is this, which I wrote as a ratio. So again, this is 1 to 5 as above. Okay. Notice that the odds for getting a 3, 1 to 5, that's not the same as the probability of rolling a 3. So they are related. They are related, but it's not exactly the same. Okay. So it's just something I wanted to bring up. That's one example. Okay, what about this example? Here, we want the odds of choosing a card at random from a deck of 52 cards. You know, we saw those cards before. And choosing or selecting a card, from a suit of clubs. So again, we're choosing a card at random. We want the odds for or in favor of choosing a card from the suit of clubs. Okay, well, how many ways can we choose a card with the suit of clubs? Well, there's 13 cards in there, right, from that suit. So there are 13 ways we can choose such a card. Well, if you want, you can think of it as probability, as I'm doing. We have the probability of selecting, selecting a card from the suit of clubs is 13 out of 52. And then we need the probability of not selecting such a card, right? Probability of the event over its complement, over the probability of its complement. And that's the complement, it's 1 minus that, which is, as you can see here, right? We have 52, 1 minus 13 over 52, and we get 48 out of 52. So the odds for choosing a card from the suit of clubs here, probability of choosing a card with the suit of clubs, probability of not choosing a card with the suit of clubs, right? We have this. And as before, these denominators cancel. We get 13 over 48. But again, we want to write it as a ratio because it's odds. So, yeah. I mean, again, I guess what you really could have also said, what I was saying at first, is there are 13 cards in the suit of clubs. So there's 13 ways we can choose a card with the suit of clubs on it. And the remaining 48 cards, okay, Oh, I'm sorry, 48, that's right. For some reason, I thought that was wrong, but the remaining 48 cards do not have clubs, okay? So because of that, we get 13 to 48. Okay, good, good. All right. All right, I hope that makes sense. Okay. Okay. So that's what we get there. So, and also you can easily get the odds against choosing a card with that suit of clubs. You can also choose the odds against that. It's really just this inverted. It's 48 to 13. There are 48 cards that don't have a suit of clubs. So we have 48 to 13. That's another way of saying it. That's how we can say the odds against choosing a card. Okay. I think something's wrong here, isn't it? I think there's a calculation error here. That shouldn't be 48. I think that should be 39. I think there's a calculation error here. I'll have to fix that. Okay, so we just fix that. I think it should be not 48. I think it should be 39. That's what it should be. Okay. Well, I'll have to fix it then. So yeah, I don't want to spend too much time on one example, so let me just skip that. We'll come. Worst thing is I bring it up again next time. But I think that actually should be 39 because 52 minus 13 is 39, not 48. Okay, my mistake. So, all right. I'll have to fix that. So, other than that, are there any questions? Okay. So this is the last thing for today, the expected value. Namely, the idea with expected value is, well, basically, let me set up the situation, so to say. What's happening is you can imagine that you're playing, like you're gambling or something, or you're playing a game or something where you could win money. If a certain outcome or if a certain event occurs, so certain outcomes occur, you will earn money. But there's also outcomes in there where you can lose money, let's say. I know in the book, they go through the game of roulette. I mean, it's not the only case where this can happen. I mean, another example I was going to do with the other class, I didn't get to it though, is you're at like a charity event and there's like some kind of, I don't know if it's a charity event, I shouldn't say that, but like a raffle or something. And if your ticket's called, you win money. If someone else's ticket is called, you lose money. You lose money because you paid for the ticket. Okay. Well, expected value then is again how is the average gain or loss of an event if the procedure is repeated many times. Okay. So again, it's the average gain. It's the average gain or loss of an event if the procedure is repeated many times. Okay? Now, there is a way to actually calculate it. They go through it in the book. I just wrote it here. But basically, you calculate it. You multiply each outcome with the probability of that outcome occurring. And then you add up the products. I mean, I know that's kind of confusing now. I understand that. When we do examples, I think it will become clearer. I mean, generally also with the outcome, you'll see what I mean when we do examples. With expected value, if you're in the case when you're losing or gaining money, okay, if the expected value is negative, you're going to expect to lose money in the long run. So again, if you're doing this for like gambling, let's say, right, and you calculate expected value, okay, if you were to calculate it and your expected value is negative, then in the long run, if you keep on playing this game, you're going to lose money. I mean, sometimes when you play, you will win, sometimes you'll lose, but in the long run, you're going to lose money. And if it's positive, okay, that means you should play. Well, so if it's negative, you should not play, but if it's positive, the expected value, if it's positive, then you should keep playing, because in the long run, you're going to win money. So sometimes you may lose money, sometimes you'll win, but in the long run, you're going to win. That said, also, the game we say is fair, okay? If, okay, we say it's fair if the expected value happens to be 0, okay? So it's fair if, if it's 0. Okay, so there was an example that I could do, but to be honest, this is where I got up to with the other class. So I'm thinking it might be good, although I guess we can look at the example. Let's do that. Let me stop the recording though. Okay. All right, so let's look at our example. So again, the first example we do actually has to do with an event where, you buy raffle tickets. Each raffle ticket costs $3 to buy. 150 have been sold, and there's a winning ticket. Let's say the winner gets $300, okay? Now, the question is, what is the expected value to you of the raffle ticket? What is that expected value? Well, what's the probability that we're going to win? Well, the way we win is a winning ticket has to get called. The ticket we have has to be the winning ticket. What's the probability of that? Well, it's 1 out of 150. So the probability then of losing would be 149 out of 50. Your ticket does not get called. And the amount we lose would be $3. But I think there's a mistake with how much we win, because yeah, we get $300, but we paid $3 for the ticket. So I'm thinking that should be $297. Let's just keep going. Otherwise, I'll just keep going. Let me just keep going with this. Let's assume it's right. So expected value would be the probability times the outcome. Your ticket's called and you win the money. And then you have the outcome where you lose money and the probability of that. Well, if you were to add these up, you get negative 0.98. So in other words, expected value is negative here. Meaning, if you can imagine this experiment or a situation to keep happening, sometimes you'll win the money, sometimes you'll lose, but in the long run, you're going to lose 98 cents. I know 98 cents is not a lot, but in theory, we should not play the game because we're going to lose money. That's actually what's happening here, okay? And I think that's actually a good place to stop. So let's stop here. Again, let me stop this.